Hi guys, good day. It's me, Teacher MJ. Our topic for today class, it's all about the kite. And we are told to find all sides and all angles. So without further ado, let's do this topic. So we have given kite A, B, C, D. Alright. And given side or line segment AD, that is 5. So this side is 5. Line segment AE is equals to 4. So this one is 4. Line segment EC is 9. And we have angle DCE. So DCE, so this angle right here is 19 degrees. And angle DAB is equals to 74 degrees. DAB, that is 74 degrees. Alright, so once again, we will be explaining this one class step by step. So do not be worried, class. We will start with the angles. Alright, let's label this up. So we have angle DCE, that's 19 degrees. So once again, angle DCE is 19 degrees. Let's find first class all angles. Alright, so once again, you look at this middle part, C. So that would be DCE. So therefore, this angle right here is 19 degrees. Alright, so this is 19 degrees. And we also have given angle DAB. So DAB, angle DAB, 74 degrees. So if you draw this one, so this will be DAB. So that is 74 degrees. Therefore, this angle A right here. So this is 74 degrees. This angle right here, class, as a whole, this one, that would be 74 degrees. Alright, so if this is 19 degrees, therefore this is also 19 degrees. Question, why is that, sir? Because the major diagonal, class, or the longer diagonal, this diagonal AC, cut this angle C and angle A into two equal parts. That's one property of a kite, class. The longer diagonal cuts the opposite angle into two equal parts. Okay, so if we draw this one, we have angle C. Okay, let me just draw this one, class, for you to understand this one. Alright, so if we have angle C, this one, class, let me just draw this one, class. D, right, C, and B. And we draw this diagonal. Once again, this AC is the diagonal. Alright, this AC, class, this one, diagonal AC, cut this angle C into two equal parts. So therefore, this angle right here is congruent to this angle. Same scenario, class, in the opposite angle. Okay, this one. Okay, this one right here. Alright, this angle right here is the same measure with this angle. Alright, so this angle right here is the same measure with this angle. Because the longer diagonal, or we call it the major diagonal, cuts the opposite angle into two equal parts. It means the longer diagonal bisects opposite angles into two equal parts. Only the major diagonal, class, only the longer diagonal cuts the opposite angle into two equal parts. Alright, so I hope you got that one, class. So therefore, we can say that this angle, okay, this angle BCE, okay, BCE, or you can read this one ECB, is also 19 degrees. Alright, so we're done with the first angle, 19 degrees. And we have given, okay, we have given angle DAB, so DAB, that is 74 degrees for angle A, this one. Alright, so I hope you got that one, class. This one right here, DAB, this whole A, that would be 74 degrees. So we need to divide it by 2 so that we can get this angle, because this angle is congruent to this angle. This angle right here, class, is congruent to this angle. Alright, since this is 74, we divide it by 2. So 74 divided by 2. So this is 3. 7 divided by 2 is 3. 3 times 2 is 6. Subtract. 7 minus 6 is 1. Bring down 4. 14 divided by 2, that is 7. 7 times 2 is 14. 0. So this will be 37 degrees, class. Alright, so let me just write it here. This is 37 degrees. Alright, and then this is also 37 degrees. Easy, right, for the kite? If you understand the properties, class, this will be really easy for your class. Alright, so 37 degrees and also 37 degrees. If you add it up, that would be 74 degrees. Alright, so we're down to 3 angles, 37, 37, and 90. Alright, so next step, class, the diagonals are perpendicular to each other. What do you mean by that one, sir? When the diagonals, class, meet each other or intersect each other, they form a 90 degrees angle. That's what we call, class, perpendicular lines. Once again, the diagonal DB is perpendicular to diagonal AC. Question, why is that, sir? The word perpendicular, class, it means that when two lines intersect to each other, they form 90 degrees angle. Okay, let me just draw this one. If we have diagonal AC and we draw another diagonal, okay, we draw another diagonal, that would be DB. Okay, DB, so this is AC. When they intersect to each other, class, they form 90 degrees angle. And this line, class, this line AC and DB, we call this line perpendicular lines. Therefore, the diagonals are perpendicular because when they meet each other, they form 90 degrees angle. Alright, so therefore, we can say that this angle A, EB, is 90 degrees. This angle A, ED, that's 90 degrees. Because this is a right angle, class. So same with, okay, same with angle D, EC, that's 90 degrees. You can actually read this one, class, angle C, ED, that's okay. Or angle D, EC, that's actually the same, class. So it depends on you, which do you prefer. Okay, you can have D, EC, or C, ED. And this one, C, EB, is also 90 degrees. Alright, so we have 1, 2, 3, 4, 5, 6, 7 angles now. So we're lacking with these two angles right here. Alright, and this one. So what would be this angle, class? This one right here. Of course, this angle D, okay, angle D, this one. Okay, let me just write it here. This angle right here, class, is the same measure with this angle. Opposite angles for this one, for D and B, it must be congruent, class. This is an obtuse angle, class, and it must be a congruent angle. Alright, so to get this angle right here, class, this one, okay, this one, we have a triangle, a right triangle. Let me just draw this one, class. So if we draw this one, this triangle right here, this one, class, we have, just write it in red, A and DE. So we have ADE. This is a right triangle, right? Sir, question, sir, when do we know that this triangle is a right triangle? We will know, class, that this triangle is a right triangle if one angle measures exactly 90 degrees. And this angle E measures exactly 90 degrees. Okay, look at the drawing, class. The illustration ADE. So this angle right here is 90 degrees. Therefore, we call this one a right triangle. So we have 90 and then we have 37 here for angle A. Therefore, to find this angle, we just need to add this one. Okay, add 90 and 37. You subtract it from 180. Question, why is that, sir? Because any kinds of triangle, class, equilateral, isosceles, right triangle, scalene triangle, acute triangle, any kinds of triangle, the sum of interior angles, if you add this interior angles, class, it should be 180 degrees. Okay, always remember that one, class. Any kinds of triangle, the sum of interior angles, it should be 180 degrees. Therefore, to get this angle right here, we just need to add this 37 and 90. We subtract it from 180 for us to get this angle. Okay, so let's add this up. That would be 37 plus 90. This will be 7. This will be 12. So 127, and we subtract it from 180. So 180 minus 127. So borrow 1. This becomes 7. This becomes 10. 10 minus 7 is 3. 7 minus 2 is 5. This is 53 degrees. Alright. So this is 53 degrees. Once again, if you add this up, 53 degrees plus 37 degrees, this will be 90 degrees plus 90 degrees. This will be 180. So same angle, class, for this one. So we have 37, 90, and this will be 53 degrees. Alright, so let's find this angle right here. Of course, we have 90, 90. Therefore, we add this up. We subtract it from 180. So, if you draw this triangle, class, this one, this is also a right triangle because we have one angle measures exactly 90 degrees. So, let's draw this up. This will be Alright, so this is D. Alright, E. And then C. Of course, we have 90 degrees here. So 90 degrees angle. And we have given this one angle right here, angle C, that's 19 degrees. And we don't have this angle. Once again, we add this up, 90 plus 19. So this will be 0 plus 9 is 9. 9 plus 1 is 10. 109. And we subtract 109 from 180. Alright, so this will be 180 minus 109. So this will be 0 minus 9, this cannot be, borrow 1, this becomes 7, this becomes 10, 10 minus 9 is 1, 7 minus 0 is 7. 71 degrees. So therefore, this is 71 degrees. This is 71 degrees. That's it, class. All set for the angles. Easy, right, for the angles? So just remember this one, class, that we always have 90 degrees in the middle part for the kite, because the diagonals are perpendicular. When they meet each other, they form 90 degrees right angle. Okay? Alright, so we're done with the angles. Once again, class, if you read this one, so naming this one, class, you can read this one as angle ADE. So angle ADE, that is 53 degrees. Or you can read this one, angle EDC or CDE. It's actually the same, class, because you are referring to this middle part. Okay, if you write this one, angle EDC, that is 71 degrees. You can also read this one, class, angle CDE, that's also 71 degrees, because that's the same, because you're referring to this middle part angle, this one right here, D. Alright, so it's up to you, class, naming these angles right here. I'm sure that you already know how to name this one. So if you want to learn more about naming these angles, feel free to leave a comment, class, or you can always message me. Our Facebook channel, same name with our YouTube channel, class. Do not hesitate, class. You can leave a message there, class. Alright, so we're done with the angles. Now let's proceed in finding all sides. So we have given side AD, that is 5. So this one right here is 5. So let me label this up. This is 5. And AE is 4. So this one is 4. And we have EC, that is 9. And we're told to find all sides. Alright, so we're done with angles. Let's find all sides, class. Now, always remember, class, that in a kite, the adjacent sides are congruent. So this one right here, this is what we call adjacent sides, because they share common vertex, which is this one, this point A. Once again, class, we call it adjacent sides when they share common vertex. So this side, these are adjacent sides. They share common vertex, that is A. And this side are also adjacent sides because they share common vertex, that is point C. And in a kite, class, the adjacent sides are congruent. Alright, so this side is congruent to this side. And this side DC is congruent to side BC. So therefore, if this is 5, AB should be 5. Okay, once again, AB, line segment AB is 5 because AD is 5. Alright, so let's find this one. Find DE. So let's draw this right triangle. So we have triangle ADE. So we have ADE. Alright, and this is 5. This is 4 for AE. Once again, class, I just wrote this triangle for us to find this side. Okay, the side right here. So ADE and AD is 5. AE is 4. And we need to find this side right here. So to find that side, of course, we have 90 degrees angle right here. Now, if you have 90 degrees right angle, class, therefore, you can always use Pythagorean theorem. Once again, if you have 90 degrees angle, this is a right triangle, you can always use Pythagorean theorem in finding one side. Okay, let's find the side, class. This one. Line segment E or side E. Alright, the formula, that would be C squared is equals to A squared plus B squared. And C, class, is always the longest side. So C is the hypotenuse. So this side right here is the longest side. So this will be the hypotenuse. Alright, so therefore, C is 5. So 5 square equals, so for A and B, class, it could be interchanged. You can have this as your A, or you can have this one as your A. So let's assume class that this is A and this will be B. Alright, so we are told to find A. So A squared, we don't have the value of A, plus B is 4, so that would be 4 squared. Once again class, do not be confused. For A and B, you can have this 4 to be your A. That would be the same answer class, or you can have this A as your B. So that would be the same answer class. As long as class, this C right here, it could never be interchanged class. C is always the longest side. So this will be 5 square, that is 25. 5 times 5 is 25. It's not 5 times 2. It means 5 times 5. That would be 25 equals, copy, A square. We don't have the value of A. Plus 4 square. What is 4 square class? That's correct. 4 square, it means 4 times 4. And that would be 16. Alright, so to find the value of A, we transpose 16 from right to left. So that the remaining equation will be A square. So 25. This is positive 16. Once you transfer from this equal sign, you change the sign. This will be negative 16 equals A square. So 25 minus 16, that is 9, equals A square. And to get the value of A, you extract square root both sides so that we can cancel this 2. And the square root of 9, that is 3. So therefore, A is 3. Alright, 3 equals A. It's just the same with A equals 3. So therefore, this side is 3. Right, this side right here is 3. So this is 3 class. This one right here is 3. And the middle part, this one. Now, if this is 3, this is also 3. Question, why is that, sir? Because this longer diagonal class, this major diagonal, bisect this short diagonal class. Once again, this longer diagonal or the major diagonal bisect the minor diagonal. Bisects the minor diagonal. What do you mean by that one, sir? Okay, this longer diagonal cut this minor diagonal into 2 equal parts. Okay, let me just draw this one class for you to understand this one. Okay, if we have line segment DB, right? Let's assume class this is diagonal DB, and we draw another diagonal. Okay, once again, we are referring to the kite class. If we draw a longer diagonal, okay, this is A, this is C. When we connect this point A to point C, okay, this is the longer diagonal class or the major diagonal. We cut this minor diagonal class into 2 equal parts. That's why the longer diagonal bisects the minor diagonal. What do you mean by that one, sir? The longer diagonal cut this minor diagonal into 2 equal parts. So therefore, this line segment, this one, okay, if we have E, this line segment DE is congruent to line segment BE. So I hope you understand that one, class. If you understand that one, very good. So if this is 3 for DE, therefore BE is also 3. Okay, BE is also 3. So this is 3. I will just write it in red, class, for you to see this one. This is 3. Therefore, this one, BE is also 3. Alright, so last one, class. We have DE is 3, BE is 3. So let me just write the value here. So we have DE is 3. Line segment DE is 3. Line segment BE is 3. Therefore, minor diagonal, this one, the short diagonal, DB, the line segment DB is 3 plus 3, that would be 6. Alright, so this is 6 for DB. Almost done. So locking this side, class, this one. Alright, so last one, class, this one. So let's draw this triangle, class, DEC, so that we can find this side right here. So we have DEC. So once again, a right triangle. This is 90 degrees. Right triangle, one angle measures exactly 90 degrees. So D, okay, we have DEC. Alright, and this is 71 degrees. So no need to write the angle since we need to find the sides. So we have given 3. We have DE, that is 3. And we have EC, that is 9. So this is 9. And we're locking this side. Alright, once again, this is 90 degrees angle. And this is a right triangle. Once again, if this is a right triangle, you can always find one side using Pythagorean theorem. And the formula, that would be C squared is equals to A squared plus B squared. And this will be So c squared, we're looking for c. Once again, the longest side, this is the hypotenuse. Okay, and the hypotenuse is always c. Alright, so this is c, the longest side. We don't have the value of c. So copy c squared equals, you can have 3 as your a or you can have 9 as your a. It depends on your class. Which do you prefer? You will have the same answer because this is addition. Alright, so let's have 3 as our a. So 3 squared plus 9 squared. b is 9. c squared equals 3 squared. That would be 3 times 3. That is 9. Plus 9 squared, it means 9 times 9. 9 times 9, that is 81. So c squared equals 9 plus 81, that is 90. So to get the value of c, extract square root both sides. So cancel this out. So c equals, do we have square root of 90, class? Nope, we don't have exact number for the square root of 90. But we can simplify 90. You find two numbers, that one number is a perfect square, the other is not. You can simplify this one by 9 times 10, right? Because 9 is a perfect square, then 10 is not. And 9 times 10, that is 90. So c equals the square root of 9, that is 3. You put it outside the radical symbol. So the square root of 9, that is 3. You put it outside. So 3. Then the square root of 10, we don't have square root of 10. Simply copy square root of 10. That's it, class. All set. So therefore, this is 3 square root of 10. If this is 3 square root of 10 for DC, this is also 3 square root of 10 for BC, because this side is congruent to this side. So this will be 3 square root of 10. Alright, so therefore, DC, line segment DC, that is 3 square root of 10, or side DC, 3 square root of 10. So side BC is also 3 square root of 10. That's it, class. All set. Finding all sides and all angles of a kite. So I hope you learned something new today. If you like this video, do not forget to like, share, and subscribe. You share it to your friends and to your classmates so that we can help more students, especially for those students who are really struggling in solving math problems. Once again, class, this is Teacher MJ. Have a great day, class. Goodbye for now. Bye-bye.